So two fairly straightforward linear equations we're asked to solve. In this first one, I'll begin by, I guess, taking away an x from each side. That's going to leave me with 3x's on the left-hand side, and then still the plus 1. And on the right-hand side, I have the number -8. The next thing I'm going to do is subtract 1 from each side. When I subtract 1 from this side, you can see these two cancel out, and I'm left with just 0 there. So now this is 3x on the left-hand side. And on the right-hand side, -8 and -1 is -9. And then finally, we'll divide both sides by 3. Right? You can see this is a giant 1. I divided by 3, and I'm left with x equals -9/3. And if I divide 3 into -9, I get that x is equal to -3. So x is -3. That's the solution to A. Let's take a look at B. On B, we'll use an application of the distributive property. We'll get rid of this grouping symbols by rewriting this as 10x plus 6. And on the other side, that equals 6 times x minus 3. I'm going to subtract 6 x's from each side. On the left-hand side now, I have 4x plus 6. And on the right-hand side, I have -3. If I take away 6 from each side, right, I'll subtract 6 from each side. That gives me that 4 times x equals -9. And interestingly enough, many of you got to this point in your groups and you decided, well, that doesn't work because you didn't like the look of the answer. But if you look at it closely, I'm just dividing both sides by 4 next. Divide this side by 4. Divide this side by 4. This is clearly a giant 1. So I'm left with just x is equal to -9/4. And that's a perfectly fine answer, right? X is -9/4. At some point, I might show you how to check that answer using your calculator to just efficiently see that it does indeed make both the left and the right hand side equal to each other. The other question on this page was, it says create a table graph equation to match the tile below, pattern below. Sketch figure 1 based on the pattern. Use one of your representations to determine the number of tiles in the 8th figure. So if I look at this, I can see from figure 2 to figure 3, I'm adding, it looks like these 5 tiles as I move forward, right? I'm adding those 5. And as I move to the next layer up, it looks like, again, I'm adding these 5 tiles. So each time I move forward, it appears that I'm adding this chunk of 5 tiles with that shape. So if I was to move back and say, well, at one point I was adding these 5 tiles, what happened before that? Well, I had just 3 tiles by itself. So figure 1 has 3 tiles in it like this. And if I wanted to, I could, quickly make a table where I'd have figure 1, 2, 3, 4, 5, 6, 7, 8. So figure 1, it looks like it had 3 tiles. The one after that, if I counted, it had 8, and then we went up to 13, and then 18. And every single time we moved forward, we were just adding an additional 5 tiles. So 23, 28, 33, and then finally 38. And if you look at it, it says the 8th figure will have how many blocks? Well, it looks like it's going to have a total of 38 blocks. I was a little bit ambiguous about what to do with this area. I did say to create a graph. I noticed that most of you, or many of you, continued this pattern and you were drawing more of these moving forward. So I didn't take off points if I saw either the graph or an extension of this pattern. That was fine this time.